Today we're going to start looking at the normal distribution curve. And if you've never heard of what that is, you may have heard of it in another way. It's also called the bell curve. And so I'll explain how we can get the bell curve and how the bell curve is used, etc. So let's say, for example, we collected the weights of a whole lot of women, like a couple hundred, 1,000, whatever. We collected the weights of a lot of women. And then we grouped the data and graphed it in a bar graph. The answer, or the bar graph, could have turned out looking like what we see in front of us right now. So if you look on the high end of the bar graph, above 200 pounds, there are very few women. And if you look at the low end, below 100 pounds, or at about 100 pounds, there are very few women. And the weights are mostly in the middle, which would make sense. Most women would be around the average weight, maybe between 130 and 170 pounds. There would be way more women in that weight range. So that's why it goes up higher here, but the bars are very low at the ends. So several things follow this trend, like SAT scores, for example. Most people score around the middle, around 500 in each subject. But then when you look at the ends, of 200 on the low end, very few people would score 200 on the SAT math, for example. And very few people would score 800, but a lot of people score between 500, maybe in the 400s, or the low 600s. So yeah, that's what really the normal distribution curve shows. It shows that bell-shaped curve that most people in collected data would lie in the middle and very few people on the ends. Now, I think it's a beautiful thing because it makes everything very, very predictable. So when things follow this format, you can judge how many people lie in the low range, the middle range, the upper range. Exactly. You can exactly find out what percent of people are in what range. So we're going to look at how to do that today. And we're going to need the official values here. So that's our normal distribution curve. Let's get rid of that one. We don't need it anymore. That's our normal distribution curve with values in it. So we looked at mean, we looked at standard deviation in our last unit. So our mean is our average, or average score, or average weight, or average of whatever we're talking about, would go right in the middle of our normal distribution curve. Then after that, we would have a standard deviation jump from here to here. That would be one standard deviation higher than the mean. Here to here is 2 standard deviations higher than the mean. 3 standard deviations higher than the mean. And then we can go in the other direction. This will become a lot clearer when we actually put numbers in and look at an example. So what makes this predictable is the fact that we have these numbers. There's another number out here, 0.1. So what these numbers do is they tell us how many people in our data are between each range. So for example, there are 34.1% of people that will be between the mean and 1 standard deviation above the mean. So as I said, this really, really comes alive when we look at an example, an actual example. So let's do that. Okay, so now we're looking at an actual example and things will become so much clearer. So the mean of a test is 83 and the standard deviation is 5. Find the probability of scoring between 78 and 93. So we're going to focus for now on the mean and the standard deviation. This symbol is used often for mean, as you may already know, and this symbol is used often for standard deviation. So in our graph, our mean is 83, so the 83 will be labeled in the center, 83. Now, for every time we add a standard deviation, we're going to add 5 in this example. So the next score on our graph would be 83 plus 5. It would be 88 right here. A little bit messy. All right, the next one will be 5 plus that score. So it would be 88 plus 5. So we would have 93. And another 5 would put us at 98. Going in the other direction, we would take 5 away from our 83 because it's minus the standard deviation. So we have 78. We would take 5 further to go 1 back, and we would have 75. And, sorry, not 75, but 73. And one more standard deviation back would take us to 68. So the majority of our people scored between 68 and 98, and then there were very few people on the end that scored above 98 or below 68. So the question is asking for us to find the probability of scoring between 78 and 93. So 78 is right here, 93 right here. So 78 is above that line, 93 is below this line. So the probability of scoring between 78 and 93 would be that value plus that value plus that value. So it's between, again, 78 and 93. So it would be these 3 values. Now these 3 values are always the same. Somebody really smart some time ago figured out that these were the percentages in a normally distributed curve. So we can use them always. So the probability of lying between 78 and 93 in this case would be 34.1, and we'll just use 1 decimal place, plus 34.1 plus 13.6. Write that again. 13.6. Oh, let's see. It's a little bit messy here. Let's just cross that off. Plus 13.6. And when we add all of that up, we should get 81.8%. So the probability of scoring between 78 and 93 would be, again, the sum of these 3 values because they're between 78 and 93, and our answer is 81.8%. So it's entirely possible for them to go the other direction, for you to get a question going in the other direction. So in this question, you're actually seeing the probability and you're asked for the score. In the question before, you were given the score or given the weight or given the x value basically, and you were asked for a probability or a percent or a chance or the area under the curve. So now we're going to go in the other direction basically. So you are in the 84.1 percentile on the Math SAT test. The mean is 500 and the standard deviation is 90. So the first thing I think you should always do is really orient yourself by getting these numbers onto the curve, the mean and the standard deviation. So we have 500 in the middle because that's the mean. And then we're going to be jumping by 90 because that's the standard deviation. So we'll go to 590. Then 90 more than that will get us to 680. And then 90 more than that will get us to 770. Alright, so we're jumping by 90. 590, 680, and 770. Now going in the other direction, we're jumping by 90 backwards. So we have 410. And going again, we have 320. And one more time, jumping backwards by 90, we have 230. So let's just check this over to make sure it's right. 230, 90 more is 320, 90 more is 410, 90 gives us 500, 90, okay. So everything looks good. We're jumping by 90 each time. And I want to know the probability that, well, actually, now we do know the probability. We're asking for your score. So if you're in the 84.1 percentile, that means you scored higher than 84.1% of the people that took this test. So since our middle is right here, approximately half, it's not quite, but approximately half of the people who took the test are below or average. Well, so approximately half of the people who took the test will be below or average. Other than that, so that's the 50th percentile, right in the middle. New York sirens, please forgive them. All right. So now that's our 50th percentile, and we want to get up to the 84.1 percentile. So we have to go 34.1 more percent. So adding on that 34.1 will take us up to 84.1. Now the score here is going to give us the 84.1 percentile, or it's going to be the 84.1 percentile score. So that means that that 590 is that score that was higher than 84.1% of the other scores, and that is our 84.1 percentile score. Okay, so now you may be wondering, what are we supposed to do if you're not asked about a nice, neat score like one of the scores that are down here? You know, so far, everything we've looked at has fallen exactly 1, 2, or 3 standard deviations below or above the mean. So it's been, you know, a question maybe I could ask about between 500 and 680, or between 320 and 410. Everything has been exactly 1, 2, 3, or standard deviations below or above the mean. If that is not the case, we will have to use our calculators to help us figure it out exactly. Otherwise, we would only be able to estimate. An estimation is not good enough. We want to be able to get an exact number for our probabilities, and our calculators are able to help us do that. So stay tuned for a future video, and you will see how.